before we go deeper into the other topics after glycolysis, I would like to take this video to briefly orient you guys on the common acids that we have encountered so far and that we will encounter later on. Well, they are divided here according to the number of carbons. Here at the top we have the 3 carbon acids, then the 4 carbon acids, then the 5 and 6 carbon acids. The 3 carbon acids are actually the ones we have most likely encountered in glycolysis, because if you would look at the pattern, almost everything starting from step number 4 consists of 3 carbons. And primarily the first one that came up there from among these 3 is this one. Alright, and if you can recall, the name of this guy right here is glyceric acid. If you're wondering why this is glyceric acid, remember that glycerol is 3 carbons, then 3 hydroxyls. Well, glyceric acid is when one of the terminal hydroxyls becomes COOH. So glycerol becomes oxidized to form glyceric acid. So that's where the name came from. And then the next 3 carbon acid that we have encountered in glycolysis is actually the one that we want in glycolysis. This one, pyruvic acid or pyruvate. And here, pyruvate is also known as an alpha-keto acid, because if this is the functional carbon, this is the carbon in the carboxyl group. The next carbon after that is the alpha, then after that is the beta. And in the alpha carbon, there is a keto group or a carbonyl group, so that's why pyruvate is also known as an alpha-keto acid. As compared to this one is actually what happens when you reduce this carbonyl group of pyruvate into a hydroxyl group. So this one is an alpha hydroxy acid, or an AHA. And the name of this one in particular is lactic acid, or simply lactate. So the relation of lactate and pyruvate is that lactate is the reduced form of pyruvate, or in other terms, pyruvate is the oxidized form of lactate. Okay, so now the 4 carbon acids, all of these are actually dicarboxylic acids. What do you mean by dicarboxylic acids? Both their terminals are carboxyl groups. As you can see here, COOH, COOH, the same. So you won't be able to see a 4 carbon acid that is not a dicarboxylic acid, especially in the Krebs cycle. So I arranged this in order of increasing complexity. We know that the COOH, the terminal groups do not change, so the only thing that's differing are the 2 carbons inside, right? Alright, so here, if you have nothing really in the middle, it's just carbons and hydrogens, the name of this 4 carbon acid is succinic acid, or succinate. If one of these becomes substituted with a hydroxyl group, alright, it becomes malic acid or malate. Now if you add another, alright, in order for you to have 2 hydroxyl groups at the 2 separate carbons in the middle, you have what you call as tartaric acid or tartrate. Now if you have malate here, alright, you have malate. If you oxidize this to form a carbonyl group, the oxidized form of malate is known as oxaloacetate. Alright, why is it named oxaloacetate? Just as a trivia, you may be interested. Well, this one right here, the half right here is the acetate portion. As you can see, this is acetic acid, right? Okay, and where is the oxalic acid? It's here. It's COOH, and the C double bond O, if you cut this, you would attach OH, and we know that oxalic acid is COOH, COOH. So that's where the name came from, oxaloacetate. Now here, what happens is that there is a double bond between the 2 carbons in the middle. Alright, this is what happens, for example, when you dehydrate malate. So if you have remove one of this, then remove one of the hydrogens. You remove hydrogen here, you get something like this. Alright, after dehydration. And the name of this dicarboxylic unsaturated acid here is fumaric acid, or simply fumarate. And now we go to the 5 and 6 carbon acids. This is the only 5 carbon acid that we will encounter in the Krebs cycle. 1, 2, 3, 4, 5. And the name of this one is Alpha-Ketoglutarate acid, or Alpha-Ketoglutarate. Where's the alpha-keto group here? It's located here. So we assume that this is the alpha carbon. Alpha-keto, and then 5 carbons, glutarate. Alright. Now, if we have 6 carbons, okay, if we have 6 carbons, it's either of the two. The more common is this one, where in the middle carbon, alright, this is a straight chain 5 carbon compound. In carbon number 3, you will find 2 substituents. 2 substituents, alright, a hydroxyl and a COOH. So if we have 2 substituents on carbon number 3, automatically, then that is citrate. But if in case the carbon number 3 only contains 1, alright, and where do we see the other one? If in case the hydroxyl group is actually transferred to carbon number 4, alright, the difference between citrate and this one is the hydroxyl is on 3, the hydroxyl here is on 4. The name of this compound is isocitric acid, or isocitrate. So with that in mind, let's go to the next parts of catabolic pathways.